Yes, from primary amines, if reacted with NaNO2 and HCl, we get alcohol, right?
Yeah, it's a good reaction. We'll discuss that.
Okay.
You discussed that reaction already?
No, sir, we didn't.
That's an important reaction. We'll talk about that now. So, first of all, let's say I'm going to be having RCH2NH2. Okay. Now I want to convert this into an alcohol. Okay. So, direct corresponding alcohol, let us say. Now, one of the simplest ways is by a process. I'm assuming you did nitrous acid type of HNO2.
Yes, sir.
NaNO2HCl.
NaNO2HCl, yes.
Okay. All right. So, now let's talk about what is going to be done over here in this process here. In this process, when you are doing this conversion here, we are going to be looking at one very critical reaction. Very important reaction of amines over here, which is called as diazotization. So the name of the reaction is diazotization.
Azotization.
Again, shitty technical name. Nobody needs to give a shit about the name. Okay. Now let's look at what is really happening here. You're going to be having a reaction of this guy with NaNO2 plus HCl. Correct?
Yeah.
Let's look at what is NaNO2 plus HCl really. NaNO2 is a salt of HNO2 and NaOH.
Yeah.
Right. So the HNO2 here is a much weaker acid compared to HCl. All right. So when you're going to be having HNO2, this is a weaker acid. Than HCl. Okay. So if it is a weaker acid than HCl, what will be happening now is a regular displacement reaction. Okay. So when you're going to be having a standard displacement reaction happening now, what will happen is very straightforward. NaNO2 and HCl will react to give you NaCl and HNO2. This HNO2 is not going to be staying simply as it is. This will react with extra HCl to give me H2NO2 plus 1 plus Cl minus.
Yeah.
Okay. So now let's study the structure of this H2NO2 plus 1. HNO2, by the way, has a structure like this. HNO2. That's all, blunt.
Yes, sir.
If this fellow is going to be accepting a H plus, where will the H plus get accepted? It will get accepted here.
H. Yeah. Yes.
Okay. So this will effectively end up becoming N double bond O. There will be a lone pair over here, of course. And we'll have an OH2 plus 1. This is the structure for H2NO2 plus 1. Okay.
Yeah.
So this H2NO2 plus 1, next step is going to be doing the obvious thing.
Yeah.
Basically, you'll end up having these two electrons being taken over by this oxygen, and this entire thing will get the hell out.
Yes. Yeah.
Basically forming NO plus 1 plus
NO
H2.
plus.
So we'll have H2NO2 plus will effectively break down to give you NO plus plus H2. This NO plus is called nitrosonium ion. And this is going to be your reactive species now, which is going to be going and doing the reaction.
Okay.
The reaction is actually even more complicated from here. It gets more funnier from here. So I'm not going to be doing the exact steps now again and again, because the steps are not going to be really important. What you need to understand is what is happening from those steps.
Okay.
So in this particular case here, what has happened so far is this. We are going to be having NO plus generated as of now. And the compound we have is an amine. Okay.
Yeah.
So now we are going to be having this NO plus is going to be reacting as an electrophile with the amine, which is the nucleophile. So you can think of it as an acid base, nucleophilic addition elimination, however you want to do it, no problem. Ultimately, what is going to be happening is very simply put, we will be having an elimination of this.
Okay.
Forget about how the mechanism is going to be. This is not going to be a one-step reaction. It will happen in a bunch of steps sequentially. And we will have this H2O getting eliminated out. If the H2O is going to be eliminated out, the guys who are left over are basically going to be this nitrogen. Let me mark
Another nitrogen.
in blue now. This nitrogen, and of course the plus one also. Because H2O will not leave in any other form. It will leave as H2O only. So what happens over here is you will be having the product obtained now being something like this. Have a look at the structure.
Okay.
This is the structure with a plus one on this nitrogen here.
Okay. Yeah.
So this is called as your diazo compound. Now this is going to be produced along with whatever was the partner for NO plus. What was the partner for NO plus?
H2.
No. The partner for NO plus was Cl minus. H2O was the other partner, but H2O was the medium. So what is the real ionic partner for NO plus? The Cl minus.
Okay.
Because the H2NO2 plus is what became NO plus and H2O, correct?
Yeah. Yes.
What was the partner for the H2NO2 plus? That was Cl minus.
Yes, sir.
That same guy only became NO plus and H2O. So H2O doesn't require a partner. So the NO plus's partner is now the Cl minus. So in this case, again, the NO plus has now broken off and become a H2O. So who is left over as a partner for this fellow here?
Cl minus.
Cl minus. So in this particular case here, this species is called as diazonium ion. The actual name is diazonium ion. So you can call it as alkane diazonium ion. And this entire compound here is called as alkane diazonium chloride.
Okay.
Okay. Now, this alkane diazonium chloride is going to be the next fellow who is going to be reacting now in the next chapter. So we're going to be having our CH2 N2 plus Cl minus. Now this is going to be reacting with water. Or you can also do H3O plus. And simple warming will basically get the job done easily. Now, what is going to be happening in this process here when you do this? You will simply have water molecule becoming the nucleophile, which will come and attack here and kick out the nitrogen as a gas molecule. So why is this reaction going to be happening very easily in the forward direction? What is going to be the product here? You will get RCH2OH plus you will get N2 gas being kicked out.
Okay.
So this reaction will be something where warming. Why is this helpful here? Because for the overall reaction, let's call this as some random reaction X over here. Or rather, let's call it as reaction 1. So for reaction 1, for reaction number 1, delta S of reaction 1 is positive. Why? As gas escapes.
Gas escapes. Yes. Delta Ng.
Okay.
Hmm.
This means we will have delta G, which is delta H minus T delta S. Let's say delta G of reaction 1 if I'm considering.
Yeah.
It's favored, which means becomes more negative at higher temperature. Why? Because delta S is positive.
Yeah.
You understand the idea here? This fellow
Yeah.
delta G will become more negative at higher temperature here. So that is why we warm it.
Okay.
Clear so far?
Yes, sir.
Now, in this process here, one thing to watch out for here. This particular step here, where you're going to be having this reaction happening, this reaction may go via carbocation formation.
Okay.
In rare cases, usually no carbocation formation, but it may go via carbocation formation in some rare cases in some specific mediums. If it goes via carbocation formation, what can it do?
Rearrange.
Correct. That's all.
Yes, sir. I think my doubt is regarding that. Like we were given a few reactions, and then the major one was the alcohol, but then along with that, elimination products were also there.
Think why? Carbocation. When you get carbocation, it can do rearrangement. But if you do carbocation and rearrangement, you can also do elimination there. Carbocation, you remember, once you get carbocation, it can do SN type or it can go elimination also.
Elimination type, yes. E1 or SNO. First step is same for them. So,
You
so like
understand the point here?
it's not like from the alcohol again, it's turning into this. It's like
Not
that is
necessarily. It is not going to be going to the alcohol stage. It will get elimination from the carbocation itself,
from the amine itself.
not from amine. After the diazonium, after this stage, this process here, this step here, which we are talking about here, this is the guy which can go via C plus formation. If
Okay.
it forms a C plus, it can do anything else. All the branches which it can open up to from carbocation, they open up.
Okay.
You understand what I mean from there?
Yes, sir.
You can
Yeah.
get a rearranged alcohol, you can get an alkene. All of those start depending on what conditions you're putting it under.
Yeah.
Because you've now got a carbocation.
Yes, sir. Yeah.
We'll be going back to our Sunday schedule from coming week onwards, dude. This week Sunday was a little tight for me. So morning we'll have sessions.
Okay, sir. Yeah.
Okay.
Yeah.
Now, where are we other than next up, next reaction which you have problems in so far, or any other reactions which you have some doubts on?
Sir, for hydrolysis of ester.
Estera, ethera.
Ester.
Estera, ethera
Yeah.
again.
Ester.
Ester, confirm?
Yes, sir. Like we were given an isotopic oxygen, and then So, like, could you write a ester with an isotopic oxygen, like marked oxygen? Yeah. Plus H2 will give a carboxylic acid and an alcohol, right? Yeah. Yeah, that's it.
Hmm.
Here, where will the which oxygen will go where? I mean, uh,
No. So this is another very famous reversible reaction.
okay. So this is reversible because it's
Stop. Stop. Don't ask questions now. Stop. Pay
okay.
attention for a bit. Now, this is a reversible reaction here. Now, why did I point out that this is reversible here? Mainly because the real mechanism to understand which oxygen is going to be placed where doesn't come from this direction. It actually comes from this direction.
Hmm.
All right. So, what is the actual reaction which you need to understand here? This is called as esterification reaction. All right. You have not done the reaction mechanism yet.
Okay.
Give you the answer for this, but
Hmm.
you've not done the esterification reaction mechanism. Now, esterification, when you're going to be considering that reaction mechanism, how is that going to be working out? So the product formed is going to be RC double bond OR dash plus H2O. Now let us mark each of these here. So let's call this oxygen number 1. Let's call this oxygen 2. Let's call this oxygen 3. Okay. What is
Yeah.
going to be happening is, depending on the R group and the R dash, you will
Hmm.
have different possible mechanisms being applicable, truly, in the
Yeah.
esterification itself. But the most common mechanism slash standard mech, for that, what will be happening is you'll have this as 3. This can be 1 or this can be 2.
Okay.
This will be 2 or this will be 1.
Hmm.
You understand the idea now?
Yes, sir.
So the exact same will happen in reverse.
Okay. Hmm.
This is for the most common standard mechanism. So this is what you memorize. Now
Yeah.
there are going to be weirder cases where you have some funny mechanisms being possible, but those are case specific type of scenarios, what you call as exceptions. But they are case specific. Think of it like that. All right. This is going to be the default setting.
Yeah. Okay.
You understand the idea here? So in
Yes,
reverse,
sir.
how do you proceed over here? Whatever is present here at this location here or this location
Yeah.
can will be here, these two. It can be either. In the sense here, this can be either 2 or 3. Similarly, this will be either 3 or 2. If this guy is 2, this will be 3. If this is 3, this will be 2. And this will absolutely be 1.
Okay.
Default setting. So think of it as default. If you're going to be having some more funny things happening there with more, if the R and R dash are exceptional fellows, default will not be followed.
Hmm. Okay.
Some special shit will happen.
Okay. Yeah.
Fair enough. You understand the idea here?
Yes, sir. Yeah.
Now, you'll be learning more about this when you are dealing with esterification mechanism.
Okay. That'll come in
This
this chapter only.
is, yeah, this obviously this chapter, it's a
Okay.
reaction of alcohols.
Okay.
Huh. Hmm.
Okay.
Okay.
Fine. Yeah.
Next up,
For now, that's it. Yeah.
for now, you are closed.
Yeah. I mean, I'll go through them again to see if I have
Yeah,
anything else.
please, please. I think I'll also close the session here today, then more or less,
Okay, sir.
because I'll just confirm. Give me a minute if I have more time or not. If I
Okay,
have
sir.
more time, yeah, we can continue. But yeah, there's a good chance I'll also have to close.
Yes, sir. That's it. Nothing else.
That's about it, is it? How about
Yes.
NP reduction? You understood that properly?
Oh, this thing. I mean, they didn't. It's like he didn't give many points based on this. He just gave the reaction. And that's it.
So you just got the reaction. In NPV reduction also, there is going to be a couple of points like this where you need to track what is going to be going where. So let's quickly discuss the what I say, not mechanism, whatever we have been given for NPV. So what is the name which has been given for it?
The reagent.
They give you the full name for this shit?
Yeah.
Yeah, okay. Let's just not bother with that.
Really.
Yeah, the Pondorf, Verli, whatever nonsense.
Really.
Okay. So let's directly go for the reaction here. So you're going to be having, give me the reaction you have learned now.
So, ketone or aldehyde plus this isopropyl alcohol gives plus this aluminum isopropoxide equilibriums to this.
Equilibriums to are,
Yeah.
okay.
RCH, like secondary alcohol. RCH plus this CH3 C double bond O CH. Yeah, that.
Right?
Yes, sir, that's it. Yeah.
Okay. Now, what is the reagent which you have used in the process here?
Aluminum isopropoxide in isopropyl alcohol. AlOCH CH3 twice one twice.
Now, isopropoxide is going to look like this.
Hmm. Oh, mine.
Oh, thrice.
Okay. Yeah.
Aluminum will be 3 plus, but technically let's not call it 3 plus. Let's just put it like this.
Yes,
Now,
sir.
let's track every bit of hydrogen which is present here. So in this case here, these two are the same, by the way.
Yeah. Yes, sir. Why did you write it twice?
The isopropyl alcohol.
I mean, like, why did you write it twice?
Because here it is a medium along with that species over there. So just by mistake
Oh.
put it twice. I did not notice it properly that way.
Okay.
So
Okay.
now in this particular case here, let me just rub off this guy then. Nahi chahiye. So I'll rub this fellow off then. Let me capture this also and then put it to this side. Okay. So you're going to be having in this particular case here, this reaction here involves each of these species over here. So let's tag them first. So let's call this hydrogen 1. Let's call this hydrogen 2. Let's call this guy hydrogen 3. Okay. So now, which fellow is going to be going where? Is the real question which we need to start looking for answers in this particular case too. So first of all, we are going to be having hydrogen number 3 being present here.
Yeah. Okay.
Okay. And hydrogen number 2 is going to be present over here.
Okay.
Are you clear with what's happening?
Yes. I mean, yeah. Hmm.
Hmm?
Yeah.
Now, what happens in the interim though is this within the reaction mechanism is these two will react as and when this particular part gets consumed. When more and more of this gets consumed, this will go and provide to become this.
Okay. Yeah.
So technically, 3 and 1 become interchangeable eventually. When they interchange, then this can become 1. You understand the idea here? First, this fellow will be only 3.
Yeah.
When this aluminum isopropoxide gets consumed, more and more of the isopropyl alcohol will react with the aluminum to give more isopropoxide.
Yeah.
As that becomes isopropoxide, this 3 will, the 1 will become 3 there, obviously.
Yeah. Yes.
Why? Because this fellow, which is
Like
present,
supplying.
it is losing the hydrogen here, na?
Yes, sir.
Every time it loses the hydrogen, it will become this.
Okay. The
And
aluminum.
when
Okay.
it becomes this 1 would have become 3.
Okay. Understood. Understood. Yeah.
You understand the idea over here?
Yes, sir. Yeah.
So this is basically what is going to be happening over here. And you can think of this as concerted mechanism. Six-membered ring transition state.
Oh.
And something like a redox. Not exactly a redox, but yeah, consider this is enough. Actually, this is more than sufficient. Now, this should be enough information to basically proceed here. So what is going to be the reacting fellow there? It is going to be a two-step reaction where first step you'll have this fellow and this fellow reacting. Second step the product formed will react with this guy. Don't bother.
Okay.
When you discuss this more, you'll learn. And for the time being, this is sufficient.
Okay. Sir.
You understood what's happened over here? Do you want to
Yes.
discuss the mechanism?
Will it? I mean, will we do it again?
Not right now. When the
No.
next one is also discussed, if your teacher discusses the next one also,
Next one
let
is
me know then. I'll discuss the mechanism. The other one is called as
yeah.
open or oxidation.
He mentioned this. He said the reverse reaction is called open or oxidation.
So if he discusses open or oxidation, then we will discuss mechanism. It will help you understand things a little bit better.
Okay.
That is going to be basically reverse in a sense.
Back.
So back is not doing it justice. Calling it back is not justifiable. So in this here, what happened over here? We had a general aldehyde or ketone reacting with a specific alcohol.
Yeah.
To give me a general alcohol and a specific aldehyde or ketone. So in the open or oxidation, I will be taking a
General
general alcohol and a specific aldehyde and ketone. So when I say general alcohol, I'll be taking say something like R, CH, H/R dash OH. Okay, I'll be taking a random general alcohol over here now. Something which can undergo oxidation. Okay, something like this. This I will now react with acetone.
Okay. Hmm.
This time though, I will be using aluminum tertiary butoxide. So what is the problem with aluminum tertiary butoxide now? There is no hydrogen here. That is this location here. There is no hydrogen there, correct? So what will happen is this fellow, that is this aluminum fellow, will react with this guy
Yeah.
to first produce that species. And then that will react with this and give you the reaction. So let me give you the mechanism. Let me give you the product here. If you end up discussing this reaction again in your school, then we will talk about the mechanism a little bit more. So what happens over here is we will be having this hydrogen. Let's call this hydrogen number 1. This will become this hydrogen here. And this hydrogen number 2 will become this hydrogen. Clinically.
Okay. Hmm.
You understand the idea here? So it will be like clinically transferred out beautifully in terms of the mechanism over here.
Hmm.
How? We will have first reaction will be this fellow with this fellow.
Okay.
Then the product form will react with this to give you this.
Hmm. Okay. Yeah.
So in this reaction here, you can tailor oxidize whichever what is a target location, target alcohol you wish to oxidize. This is what is going to be your opener oxidation. It's depending on how much importance your system seems to be giving it. We will
Hmm.
talk more about it later. We will
Okay.
close the session here. I will see you on mostly Sunday,
So,
maybe Saturday. What is your status otherwise?
so Saturday I was school.
I know.
Yeah. I have another class on Saturday. I'm not too sure, sir. As
Not
well.
sure about Saturday.
Yeah.
All right. Okay. All right. So I'll see you mostly on Sunday then,
Yeah.
morning then as usual.
Sir, like after preparation methods, what else will come? Like reactions and
Yes.
react. Okay. So can I do questions of this chapter like
Please do.
with the
You
present,
should
like
start.
with just this?
What does with just this mean?
I mean
You
preparation
understand that
method.
organic is always cumulative now.
Yes, but like
So
I mean like
yeah.
okay.
So you have that. See, as you progressed in organic to a good extent now, we will end up having more of these cumulative parts anyway coming in. So when
Hmm.
more of these cumulative parts are coming in,
Previous methods.
we will basically end up having, or you will have more room to try out questions.
Hmm.
So you are going to be having more room to try out questions certainly now. So yeah, you
Okay.
can certainly start.
Yeah.
In fact, I recommend that you start. At
Okay.
least you start with revision of alkyl halides and Grignard at least to an extent. Grignard may
Okay.
have enough alcohols parts coming in. So
Hmm.
once you can definitely, you should definitely start.
Okay. Hmm.
Okay. Anything else, dude?
Hmm. Sir,
Hmm.
the reshuffling test result I asked my teacher.
What happened? How bad?
Uh, it was, I mean, relatively, I think it was okay, but could have been like mains. I got 194. There was rank was like around like they didn't tell the exact rank for mains, but it was somewhere between 8 and 18, something like that.
What?
Yeah.
In the entire group.
Yes, sir.
So your friends are a bunch of liars.
No, what? I mean, they got what they expected. I think.
Okay, we will close off. We'll have this conversation later. All
Oh,
right.
okay. Right,
Bye bye.
right.
I am
Thank
interested in the results though.
I don't know the sheet. They just told like orally. So like this.
We'll talk on Sunday. I actually have to go now. Bye bye.
Oh,
Have a good
thanks.
night.
Good night, sir.
Yeah.